Hi everyone, and welcome to another part of the Solidity tutorials. In this part we're going to create a contract for creating a decentralized exchange. Decentralized exchange, or DEX, is a kind of exchange that is not centralized like most of the exchanges, so there's no central authority to have this supervision over the users. So it starts with a smart contract, and it's a kind of a DApp, which is a decentralized application. So in this tutorial we're going to create a very simple kind of decentralized exchange, a smart contract. This is the most simple kind of DEX a smart contract that you can create in order to see how it works. So once you learn how to create this kind of smart contract, then you can make even more complex kinds of decentralized exchange smart contracts and get into more commercial experiences. So right now let's create a contract here, call this dex.sol. And as always, let's copy and paste the first two lines for the license and version of Solidity. Now let's create a contract called Decentralized Exchange. So let's open the brackets and address public, define the address public owner. The owner is the person who enters or deposits his or her money into the decentralized exchange for trading. So let's create a mapping here from the address to uint 256 balances, address to uint 256, and then balances. So this is a mapping for the balances of the addresses, and we've got an event for the deposit. Deposit is when you send your money to the exchange for trading. So address, indexed account, and uint 256 amount. So the account and the amount are the two parameters that this event gets. And another thing we need to define is another event withdrawal. So event withdrawal, so it gets the address indexed account, and uint 256 amount, just like the deposit. So we got another event for trade, event trade, and then it also gets address indexed buyer, address indexed buyer, an address indexed seller, an address in and uint 256 amount, and uint 256 price. So address indexed seller and uint 256 amount, and also uint 256 price. So that's it for this event. And now let's create a constructor. Open the parentheses and close this. It gets nothing. So the owner, only the owner is the message.sender, msg.sender. So now let's write the function related to deposit. So function deposit, and we'll get the uint 256 amount, public payable, so let's open the brackets. Oh, and here uint 256 amount. So function, and it will require that the amount be greater than 0, amount greater than 0, otherwise will allow the user know that invalid deposit amount, invalid deposit amount here, and then we'll have the mapping balances of the msg.sender, msg.sender plus equal the amount. So we'll increase the balance of the message sender by the amount, and we will emit the deposit event, emit deposit the msg.sender and the amount. So now it's time for the other function, function trade. So the function trade gets the address seller, address of the seller, and uint 256 amount, uint 256 amount, and then also uint 256 price, uint 256 price. So it's a public function, and here we go, the function gets started. So there are 3 requirements that we have here. The first one, it requires that the seller not be the address 0, seller not equal to address 0, and also and otherwise invalid seller address. Here we go. And the other requirement is that the seller not be the message sender, not equal to the msg.sender. Otherwise, we'll show the user cannot trade with yourself, cannot trade with yourself. So the reason we do this is that the seller, actually when we want to create a trade, so as a message to the sender, we enter money, deposit some money, but the seller who wants to sell a kind of a token or a product. So actually here, because this is a decentralized exchange, he or she wants to trade a token or coin or something like that. So all you need to do is to also let the seller to also deposit some of its coins or tokens, so that you can trade your tokens with his or her tokens. So here the seller shouldn't be you as a message sender, because you are the buyer, he or she is the seller. So you deposit some Ethereum in order to buy some tokens or coins. So the seller is another person, except just rather than you, another person who is not you. So if you yourself be the seller, then you will see this cannot trade with yourself. This is why we write this requirement. So it also requires that the balance of the balances of the message.sender, msg.sender, be greater than or equal to the amount, and otherwise insufficient funds here. There we go, and here it is. So uint256, we will declare uint256 total amount equal to amount multiplied by price. And it requires balances of the seller be greater than or equal to the total amount. So otherwise we'll show to the user seller has insufficient balance. Seller has insufficient balance. And here we go. So then the balances of the message.sender minus equal to amount. So we will decrease from the balances of the message.sender, msg.sender, to be minus equal to the amount. And also the balances of the seller be minus equal to the total amount, and balances of the msg.sender plus equal to the total amount. So actually the buyer, who is the message.sender, will pay something which is the amount from his or her balances, and you will get the total amount, right? So the seller also pays with the total amount, which is the amount he or she wants to sell, and you want to buy the total amount, so you give the amount to get the total amount, right? So because this is a very simple exchange, we wanted to make this example as simple as possible. We've created these variables, but it's more complicated than that, and it might not make any sense for you, the amount and the total amounts, because most of the time we exchange a coin for a token or another coin, but here we just sharing the same coins with their own values. So it might be a bit ambiguous to you, so it doesn't make sense, but once we run the contract, you will see that how it works. So emit trade event, so msg.sender, and the amount and price. Here we go. So we've emitted the event, and that's it for this function. So this is the trade function, and the next thing we need to add here is receive. So receive function, actually this is not a function, so we just write this external and payable. Here we go, and also fallback parentheses external payable and parentheses. So here we go, the project at the smart contract has been completed. In the next video we will compile it, find the problems, and then we will go after the deploying it.